my go-to high-speed bits in here, and we touched off on the center. We're just coming across the face now with our first cut. I am using Lumitap, and I just put it on with my brush here. I actually should go get one of the cans that one of the guys gave me so that I could get some testing going on the gifts that have been sent in, but I just haven't had a chance to get them off my desk and just get into it. So, all right, we just got a smooth surface all the way around. There's a little tiny spot in there, and here's one little low area here that we haven't quite got down, but the rest of it really does look nice and solid. Our bond, our weld, these are areas that just haven't cleaned up yet. They're not porosity or holes or hollows in our work itself. And the other thing we stopped here to just double check, and we're at 8 inches 600, give or take 10 thousandths there. And we need to go down to 8,470, something like that. I got to look at our notes that I have over there, and so we're going to take a few more passes off of this, and we've been going in both directions, just planning out. Of course, we're not taking a fine amount yet, but we're getting a better finish going in than we are going out, and so we're kind of playing that game of figuring out what's going to give us the best finish on the way out. We're not really looking for a super glossy on here, because the cast material on this rod here don't give you a super gloss on a roughing cut pattern there. It had to be polished up with something other than a tool bit to get a gloss out of cast or this rod here. Off of the material there, starts drying, it starts piling up. You probably would cut even a little bit better with flood coolant, just to always keep it on there, but it is moist, and this Lumitap does work really good there. Alright, we're 100% now on the face there. Even this area right there, it's cleared up. That's cleared up. There and there were our only two spots. And now we're like at 8,575. Alright, we're going to continue whittling it down, and we'll bring you in when we get this face on the complete side. Alright, we got our high-speed boring bar in here now. We're getting ready to kiss in on this diameter here. I feel good on our length right here. We're within, 10 thousandths or so. The other end is an open face, and then this right here within 10 thousandths or so is going to have a straight bore, and we're going to have an O-ring depth here that we're going to create a seal. So what I'm doing now is we're just going for a clean minor diameter right now, which will blend in with this minor diameter in here. I gotta get my hat so the light isn't shining on my glasses here. Alright, now we're in business. Alright, we're just starting to come in and touch the top of the weld beads there. We've got rid of the flashing from the inward direction that rolled over on the inside. So I think we're going to set up a dashboard gauge here to go along with my dial. Alright. I'm just going to take like at a time heading in here. Reduce my speed. Alright, we blew it out, and 3/765 is basically the diameter that we're supposed to have in here, and it's this is just rough because I'm using my dials here. 3/655, 3/660. I thought there was two places straight across from each other, but there's not. So we're in a rough state here. I like the finish where it has cut. It really does. We actually have two spots now that are straight across from each other. Get some air in here. All right, 3/685. Alright, we're going to keep whittling it out until we get out there. We're just taking small bites here so we keep the nice finish, just so it doesn't gall up here. And we're at like 715 now, so we've got about 50,000, a little bit more than 50,000 to go. We have one little porosity right in there, but that's where the O-ring groove is going to go, and it looks very shallow, and we're going to be removing more depth into that area right there, so in both directions. This is way inside the O-ring diameter, and this just happens to be where we were out into the main cast area. We did have an area where we were fighting the poisons and stuff near the edge, but this isn't dramatic at all. The rest of it actually looks really good. And our main area where our seal is, we've still got the integrity out in here, and that's what we're shooting for. Alright, we got 30 to go, and we're going to go ahead and take another 10,000s here. Okay, this is where we were telling you about, or talking about, how much we're actually going to shrink in the whole bore itself. We have a hollow here. We're coming in there a little bit. We're solid here. And we're having a hollow here. and we're coming in here. So we got two spots across from each other that we're coming in. We got two hollows this way here, so it is kind of somewhat egg-shaped, but we have a long enough reach here that we should be able to come in and blend in the diameter that it used to be, or it's supposed to be. And now we're gonna look in here. This is mellowed out. Quite a bit of materials come out of there, and we got rid of the spot there, and the other spot that was out here close to the sealing surface is gone. So it was just a little inclusion just on the surface of the weld itself. We still have just a little bit right there, but nothing's going to keep us from having our proper sealing surface right now. I'm going to get my snap gauges because we're going to measure what we've cut, and then we'll go for a final skim. Okay, 752. Seven inches, or 7 inches. You're reading a number that comes right to your mouth. We got 3 inches, 752, and we really wanted 3 inches, 765, give or take a thousandth. It's all clearance that's in there, so we're going to go ahead and we're going to crank in 6 thousandths, and then we're going to let it feed in until we get into the center section here. I'm going to, just for the heck of it, I'm going to snap one spot in here. I know that we did this all beforehand. And that is like 60. Let's go ahead and sneak up on it just so we're not taking the whole amount. Play it on the safe side. If it fares in, like if we get in there a little ways on the other side of this opening right here and it starts faring in and it looks good, we'll let it go like that if it's a little tight. We know it's all clearance, alright? So alright, there's our 0. Just lightly rubbing it. 4 thousandths. Don't stick the brush in the hole. Okay, and we're hollow there. We're going in a little bit there. I kind of feathered it out. Hollow, solid, hollow, solid. Alright, so we're even and we're uniform, and I like that. I'm going to go ahead and move this back, and we're going to get the cooler, and we're going to slide the cooler into there. Okay, and that cooler is going to be going in this direction here. Oh, we're against the chuck. I was going, wait, why is it stopping? And I can hear, you hear the fins? The fins are supposed to rub the board. They're creating the path for the flow, and then these bronze rings right here are kind of your chambers. And then you can see how you're blocked here, blocked, open. That's how it makes its path from one port to the other. Alright, I'm happy with that diameter. Okay, I'm getting ready to put in the O-ring groove here, and I've got the O-ring out of the package there, the new one. And we're about 115 or 116 thousandths on it, the thickness. And what I'm trying to do is determine the actual depth. I did take readings and everything else when we were facing off, and I was somewhere around 90-95 thousandths as I was skimming a little bit off the face at each time, that finally I got to the end there. General rule on O-rings through the years of working with Parker's O-rings and numerous kinds and everything else, and they all have a little bit of variation, but general rules for a static O-ring seal is about 20 to 25% compression, and if it was like on a piston or it had dynamic load, I think that's what you call it, where you got one part sliding and the other one, you have to have a little bit less, because there's a tendency for O-rings to roll if they're forced against each other, or moving parts. So the load pressure rating for a piston and stuff like that is like 10-15%. So just taking the general rule, and that was 0.115 on the width right there. Let's go times 80. Let's go that'll be 20%. That's 92 thousandths. All right. So I'm going to go ahead and create a groove here, and I'm going to shoot for right between 90 and 95 thousandths on the depth, and I'll be happy, because I think that'll be in the ballpark. That would be a good safe seal pressure for this, and very close to what was left of that groove that I could actually measure. And we did. And see my notes here. See, OD was 3 inches, 937. So here we go again. All clear. Okay, 0.9375 minus the inside diameter there was 3765. Divided by 2. We're only coming out about 86 thousandths is the difference, or the register there, diameter of the landing. So there again, it's going to force, I guess, a little bit of tightness in on the O-ring itself. The O-ring. The O-ring, when this gets slipped in there, rides right in that area right there. Okay, so it is being squeezed against this and against that face right there. Then there's a gasket that goes out here and seals the head on the end. So let's go ahead, and we've got a destination now. put us out of that diameter. This would be 85. Okay, and this should be 3937, and we're at 3932, so we actually have about 5 thousandths more to go on the OD. And let me just check the depth here real quick with this, and I'm reading 95. There's 2 O-rings in the kit and one goes around. Okay, I guess that is. Alright. I like how that feels and everything else in there. Cool. We're going to polish that just a little bit, and I am going to go ahead and take that extra 2.5 thousandths off each side there, just make sure that I got the width the right, or the diameter the right way. Alright, I like that. I'm gonna rub a little paper on here. That looks pretty good. Let's bring you in for a close look. Okay, I got you over here on my side, and I brought the light over this angling this way right here. Here's a couple of those little porosity spots that I was looking at, and here's a couple of the other ones in here. They're in here. That's where the weld was kind of like meeting up with the cast on the outside surface. Right in there, this was like one of the lows, and this was also one of the low areas right in here. There's a little remnants of the weld bee right there. Okay, you can't even feel it with your thumb. You can see it. The paper almost completely took it off. But all I was doing was I just wanted to make sure that that was smooth in there. But even though you have a couple little spots right there, there's nothing on that O-ring seal face on the outside or the face itself. Happy camper. Alright, so now we got some holes to put in, and then we're going to be redressing this face along here. There's you can see the porosity in around those seal areas right there. And this is a solid block off area right here. There's a gasket. I guess there's something that comes in here and mates up. I don't know if it's goop or whatever. That's something that I haven't seen. I've only seen this part here, and I kind of got the housing and the core, and that's it. All right, let's get this pulled out of here. Actually, before I do that, I just don't want to knock off my indicator. Okay, let's pull this out. Alright, our aluminum shims. Alright, let's head on over to the mill. Alright, this particular hole pattern, even though we were showing you how to measure a bolt pattern and comparing inside and outside, if it's a uniform pattern, you can measure your bolt pattern and establish hole center in that fashion. And this pattern that's actually on this cooler here is narrower here than it is here, and narrower here than it is either direction there. But the hole in the center is center of this pattern itself. This is loose here, and this doesn't really register here, so we can't use this to transfer. So we're going to grab the intercooler, which fits nice and snug to this piece here. We're going to go ahead and knock out, we're done with this because we don't have to grab a hold of this anymore. Everything's going to be done in a clamping down mode there with our same fixture that we had before. So we're going to take the wooden handle and okay, and we'll go ahead and wipe the little bit of tap fluid and stuff out of there, and we can set this off to the side. Now we can pass our intercooler through there and transfer punch our hole center right into space. Okay, we know that this is the narrow section, we know that this is the narrow section, and also the pattern of where the coolant or the oil flows in and then starts its channel. These two are the facing direction of those ports. Alright, now we just rotate this so that the flange is uniform and lined up here. We're happy with that positioning right there. Alright, we're going to get our transfer punch and mark those holes. We're going to go get a little C-clamp, probably to hold this in place. Okay, I rounded up one of my old bearing supports, which lets this sit right down in there. I like that. Very nice positioning. Okay, I don't think that's going to be moving or rotating around, so I'm not going to bother with a clamp. We do need a small hammer. Alright, we located a small hammer. Now I'm going to eyeball these. Actually, that handle's a little bit in my way there, so I like that. Okay, as you're going down with the aluminum, and I'm giving a good dimple there because I'm going to locate the holes off of those. But I know that when this is located in there, it's in that, it's right inside that flange ring right there. and just double checking that they all correspond with each other. That looks good. Alright, let's get ready to drill that. Alright, we're going to slide this on over here, and hey, just for kicks, I think let's stick a piece of key stock in here. Alright, now I can put this across here and make it fairly square. We should find some similarities in location. Going across from these two and going across from these two should be pretty close to being straight in line without having to move it around too much. I put this on backwards. I just like to have the curve or the pressure coming back the other way once in a while on these clamps. All right. Now I want to come in with my coaxial indicator with my center point finder. So I'm going to pop this chuck out of here because we're running out of height here. Alright, we put in our 3/8 collet here so that this coaxial indicator can go right into it. We pop out our attachment here. This is a spring-loaded pointer that made for the coaxial so that you can actually locate center punches, and we're going to go ahead and guesstimate our center here. Okay, we eyeball circle around it. Bring this line down to the line there, and lock our tables, and we're going to double check, make sure our throw is on. Alright, we're happy with that. We don't like it when it doesn't have any movement, but when it has a little bit of movement and you can take it and wobble it out and then bring it back in, maybe even go past it, I'm happy. Alright, we located that center point right there with the coaxial indicator. Okay, we're all tight. We got the chuck in here. Now I always double check, and sometimes I'm actually, this is all I use to go ahead and eyeball center to that punch. Okay, so I'm verifying, and I also, you can turn this on too just to see if you got it running out on your tap follower. This is it's a pointer and a tap follower. I mean, it was basically designed to follow a tap, but I use it as a pointer a lot of times. This is real accurate. They make those really nice, at least that manufacturer, and the lettering is worn off of this now. Alright, let's grab our helicoil kit and check that out. Okay, this is our 8mm by 1.25 lead helicoil kit. The only thing about these kits sometimes is the hinge on here and doesn't want to lay flat. Okay, we have the drill, the tap, the knockout, the tool to insert, and we have inventory on a pretty good amount of coils, at least enough to do what we need to do today. And this is a 21/64 drill, and they install it in a kit, but you kind of always want to kind of look in here, and it should give you 21/64 high-speed drill. It gives you a listing of everything that's in here, so you want to double check, just make sure that you put the right drill back into the kit. Now this one here is a through, completely going through. And I'm not finishing off any of this outside stuff here until we get all of these holes done. And I'm spinning this up here, oh, about 660 RPMs or so. I'm going to move the kit out of the way so I don't fill it with chips, and I'm going to go get some aluminum tap so that we have nice crisp cutting going on here.